Oh my god. It's alive! After numerous days of working on a concept that I have, it is finally alive and working. And oh my god, I'm excited to show you this. If you didn't see, a few days ago I had something of an epiphany, a conceptual idea around what I was calling at the time car area networks. And it was the idea that maybe I could build a series of Arduino based devices that are interconnected wirelessly in some way and have one of them be a control server which then can update everything about all of the other devices, basically creating like a centrally managed Internet of Things for your car. The broad concept was that you could create Arduino ESP32 powered devices that do things in your car that you want to achieve, but using a standardized system which then a centralized server that I create could communicate with, and then that server, despite not knowing anything about your devices, could be used to control them. It's taken a few days back and forth refining the code, but I've got something working. So before we dig into it, let me just show you what it does. So let's take a look at our devices and what we've set up. First one, we've got, like I say, 3 ESP32s. This one over here has got one button on it and it's connected to my computer, which is giving it power. Plus it's allowing us to monitor the serial outputs. That's going to become important in a minute. We've got a second one over here, which is really just a downsized version of the brake light controller system that I've been building for my car. It's got 2 buttons, one for the brake and one for the neon. We can see it. Brake makes the brake light go brighter, neon makes the neon light color change. That's all that does. So this is a simplified version. I've removed all of the code that actually does the changing of the color and all that, because that's no longer going to be applicable to this lights module. And this one's actually being powered by an independent 5-volt regulator, but the power input that I've got for it is only 4 amps, which isn't going to be sufficient to power everything and all of the lights. Hence why only 50 of the LEDs are showing up. Otherwise, it would freak out that there isn't enough current to power everything. So we're just, using a small amount purely for demonstrative purposes. Then at the back, we've got the server. So this is again connected into the computer. You can see there's no light on it because it's currently off. And it again has 2 buttons. So what does this whole thing do? If we take a quick look at the IDE, because we need it in order to see what's going on, we've got 3 Arduino packages, one for the what's called the tell time, which is this one, because when we press this button, it tells us what the time is. We have one for the lights. It's a bastardization of what I did with the lights software before, but with a load of new stuff in it. We have the server code, and then we have this just include a H file, which has got structures of data, which I'm using to pass information back and forth. We're not going to dig into the code now. What we are going to do is look at the serial monitors to see what is happening. And the first thing I'm going to do is plug the server in, because it's not currently plugged in. And we'll see that this one here should connect and do a bunch of stuff. What it does in detail doesn't matter right now. We'll get into that when we dig into the code after I've shown you what it does. But really, it's sending off to the brake lights, this ESP32, and asking it what options it has, and they're sending them back. And then it's doing the same with tell time, and tell time is sending it back. And then it's creating a menu based on all of the available options for these. So if we spot here, label DRL type 0 value 1, so that's the daylight running light, which has been sent by the lights module. The type 0 tells me that it's a switch type, so it's something that can be on or off, and it has a value of 1, which means it's on. As you can see, the daylight running mode is on. If I was to press this left-hand button here, that will change to brakes, which is the next menu item. And then if I go more, we've got glow, we've got the color red for the glow, the color green, the color blue, the normal brightness, and the max brightness. So as you can see, these first three, daylight, running light, breaks, and glow, are all type 0. So it's telling me they're switching types. They're currently all on. The red, green, and blue have got values at the moment. Red is 255 and blue is 255, which is why when I press the glow light button over here, it goes purple because it's red and blue. And they're a type 2, which is a color type. And then there's a normal brightness value 100, which is this brightness level. And then when I press the brake light, it goes up to the max brightness, which is a value here, which is type 1. And type 1 is a range, so between 0 and X. But obviously there are two devices here. So when I click the button one more time, it'll tell me tell time, which is a type 0. So it's a switch type with a value of 1. So that's what this thing does. So if I press this button over here, and we're on the tell time IDE, we'll see time since startup, 1 hour 37:46. So every time I press this, it basically just prints the time in the serial. It only does that and prints to the serial because I couldn't find any things like more lights or buzzers or something that could make an audible or a visual representation of something being turned on and off. So we have that button that spits out the time. That's what it does. And then, as we said, we've got the lights over here that have the two modes that can be changed, and then the server. So if I press the server change button to move it to glow, so glow lights work. If I then press the other button, glow successfully changed to 0. So now when I press the glow button, nothing happens because it's been deactivated in the settings in this Arduino. But this one knows about that. Similarly, I can then press the just the enter button, I guess, again, and it will change glow back, and suddenly glow's reactivated. And if I go all the way around to DRL and I switch it on or switch it off, it turns off DRL because DRL no longer works, but brake light still works and glow light still works. And then I can turn it back on again. And you can see how quickly it does it, off, on, even though these are not connected by anything other than the ESP-NOW connection. Then, if you remember this one, so it prints the time. So if I press the menu to skip through until I get to tell time, and I switch that one off, when I now press this button, tell time doesn't print to the serial because it's turned off. If I turn it back on, it's now printing again. So that's very, very, very loosely the thing that I'm building. It's a centralized control system that can control all of this stuff. The thing that's really clever is that when this starts, all it does is get all of the information about what the other devices can do from them. So it just comes alive and it says, what can you do? Send me all of your settings. And then it just builds a very, very crude interface. At the moment, our interface is just one menu option, a line at a time, switching through. That's obviously because this is just an alpha level. It's not even alpha level, it's pre-alpha prototype, just to see if we can get it working, which quite clearly we can. So really what will happen is all of those menu options will be replaced by a visual menu. I'm probably going to do it as a probably around 5-inch touchscreen where we can scroll through all of the options and switch them. But yeah, what it can then do is manage all of the devices. So I can create a new device with a bunch of things like range sliders, on-off buttons, colors, whatever they might be, and just visually display them in the server and then send those settings back to the individual devices around my car. What it also means, which I think is the best and most exciting part about it, is when I have finished it, I can create it as a package that you can include in your own Arduino stuff, and it'll handle all of that management and like requesting all the data and all the formats of the menu options and all that kind of stuff. It'll do that all for you. All that you'll have to do is make sure that, like in here, we have this structure of data. So long as your structure of data telling the server is in the right format, it should do it all. So this, I think, is really cool. Now, right now, I've only, like I say, because it is so early in the development cycle, I've only implemented the switch types, the on-offs. So if I go into one which is like red, and I press enter, it just says enter because it doesn't know what to do with that, because really one button isn't a good way of changing a range slider between two values. That will come in as and when I start putting more user interface stuff into the server. But the important thing for me at this point was making sure that those communications could happen. They were basically instant. They didn't affect the operation of the other devices too much. And yeah, that in principle, it all worked. For those of you who just wanted to see this cool thing working, that's probably enough video for you. Be sure to give it a thumbs up if you think it's something that's cool and you would like to see me develop on. If you're the kind of person who wants to dig into the how does this work, stick around folks, because we're about to do a deep dive. Okay, we can start by just unplugging all of our devices because we're not actually going to be using those for this deep dive. What I am going to be using is my old readers, which are knackered now. I stood on them again. Fortunately, I have new ones arriving tomorrow. So stylistic changes ahead. How exciting for all of us. Let's ignore this tell time application because it's basically a slimmed down version of the lights application. And we're going to look at lights, server, and this one, the vcan-h. This is just a include file which I've made that defines data structure, and it's called vcan-h because I've been calling this application vcan, Valentine's car area networks. There's nothing if not self-aggrandizing. Really, all this include file is doing for now is defining the structures of data used throughout the application. Because we're using ESP-NOW, which is a protocol for very quickly and succinctly sending information between ESP32 devices, what it does is it has to verify that the structure of data that is being sent is the same as the structure of data that's being received. So if we're sending an ID, a name, a type, and a value, it needs to receive an ID, a name, a type, and a value. And they need to be in the same format, else the thing that's receiving the information will reject it. So it's best to just have a file like this that stores the structure of the data that we're using to pass information back and forth. Let me just give you a quick run through it. This is obviously, like I say though, very, very early stage prototype. So this is liable to change as I create this into something tangible that you can use for yourself. At the moment, I only have 3 types of input. A switch, which is something on and off, a range between, so setting between a number X and Y, and a type color, because we know a color is always predefined as 0 to 255. Really, it's just a special kind of range. Then we have 5 flags. Flags are used because we want to not necessarily send the same format of data all the time. So if I'm sending a request, it's not the same as if I'm sending an option changing value. So I have 5 different ones that are passed between devices, and these all have as their first object in them, they all have a flag. And that's the name of these 5 flags at the top. So option data, request, response, message, and set value. We'll dig into them in a sec. Then we've got what I guess is like subcategories. So if I'm doing a request, I can request certain things. And at the moment, all I've done with requests is option count, which is asking how many options do you have. And then requesting an option, which is saying, give me option 1, give me your first menu item. We've got response option count, which is, it's a device sending back, this is one of my options. And then we have three messages, a success, fail, and a set success, which we use separately. And a couple of just bool operations, option being on and an option being off. Then we've got our 7 kinds of structure. The first one, well actually the first 2, are static structure types that are only used in the server. So at the moment, like I say, this is all liable to change. At the moment, they're only used on the server for verifying its structure types. So we've got addresses. A server needs to store the MAC addresses here of the devices that it's going to talk to. This is going to be, when we build up the application, a settings page where we can go in and say what the device is and what its MAC address is. And that's one of the only caveats for coding that anyone's ever going to hopefully need for using this setup. You're going to have to manually add in the MAC addresses between devices. So we format that data to the name of the device that we're talking to, what its MAC address is, and well, we make it initially 0, but this will become the number of options that that device has sent us. It's just good for management of you know, the UI. So we define that structure, as I've just seen, just a label, a byte of 6 MAC addresses, and the options count, which is an integer. Then we have a menu option. So a menu option structure is exactly what it sounds like. It's a UI element. It's a thing you can interact with, and it has the client ID. So from the device that it's sent from, the ID of the individual thing, its label, its type, min range, max range, and value. Min range and max range are optional, like if it's a switch type, they're not used, so they would be 0. But all that information is there for every single one of the menu types that are defined in the package. And we have like 5, which are the various ways of information can be passed between a client and a server. One of them is obviously menu options. The big difference here is we don't have client ID, because client ID is inferred from the server. So the server is the only one that cares what client ID is. You know, a light and a time device like this don't care who's 1 and 2. The only one that cares which one they are is the server, because it has to decide which one it wants to communicate to. So it doesn't have that in the information that's passed back and forward. It does have the ID, label, type, min range, max range, and value. So it's all the same, except it lacks that client ID, but it does have a flag option. Then there's 3 types of kind of like simple communication: a request, a response, and a message. I separated them into 3 because it made the handling of what we do with them a little bit easier. So there's a request, which is basically one device asking another device to do something. For example, give me something. That's a request. A response is exactly that. So after a request has happened, a response happens saying, I've done that, or I've not done that, or whatever it might be. Then there's a message, which is just information passed from one device to another that requires no response. So they're just like 3 typical ones. The only difference really is requests and response have a value attached to them. For example, count, whereas the structured message is just a message, so it would be a string really, but we don't use strings as much as possible. We use int messages, which we then define here. So if I want to pass a success message, I pass this variable message success as this int message, and then I know that it's message success on the other side. And then finally we've got set value, which is exactly what it sounds like. It's either the server telling the device to set a value, or it's the device telling the server that a value has been set and to update itself. It's a two-way communication, and you'll see why when we get into it. A lot of this is about error catching and validation that things have happened. I've tried to think about it in a reasonably robust way that catches problems. There are still issues that need ironing out, but like I say, it is an early prototype. So there's bound to be loads of stuff that needs doing. And then we have this union at the bottom, and that just merges all these things together. So when I'm using it later in the code, I can just use union messages, and I actually bring all of these types together. You'll see that. That's basically for when we're using the flags and deciding which one of these data structure types we're using. So that's our structure definition. Not all that difficult. What we're going to get into now is server and lights. They are quite different, but there are a bunch of things that are the same. So really the big difference between them is server is like brainless. It doesn't do anything. It just asks other things what they can do and then tells them what to do and what they can and can't do. Whereas a device, so this started as a piece of client application, which I got working that just set values on and off. And then it's also got the code around that, which functions what that device actually does. So in this case, the lights one, it has the code in there for switching the neon lights on and off, and it has the code in there for the brake light system. It doesn't have any of the Bluetooth connection that we did have in the original one, because all of that connection is now needs to be implemented into the server, because the UI now needs to dynamically update based on all of the devices that have connected to it, rather than us connecting to an individual device. So that's still to come, and that will be a future video. But really, I'd say we're going to have to, what's the best way to do this? The best way to do this is kind of side by side and seeing how the information is passed back and forward. And I'm just going to close down these outputs here, because we'll give us a bit more space. So like I say, this is using the ESP-NOW package. It's actually really easy. The only thing that will sometimes catch you up is those data structures. Otherwise, the way that it sends information back and forth is super simple. So let's start by jumping into server. We've got some state management. So the two buttons, the button that goes next to the menu and the enter button, they've got state management on them to stop them continually firing in the loop. This bit still needs some work. So when server is done properly, you'll have a settings screen that you can go into and define a label and a MAC address. So you can say, I've got this device that's called brake lights and here is its MAC address. At the moment, it's just done as a static data thing, so this will change. So we need to internalize that in memory, like I said, as will this device count. That will be inferred from this list, but at the moment it's static. So that's just our addresses of where we're connecting to. Options count is a running total. So at the moment when it boots up, it doesn't know that any menu options exist. And the current option count index is just because I have at the moment the simplest UI. It has one line of output at a time. So I'm just looping through it. So again, a lot of this stuff is going to change when we come to doing the application proper, because there'll be a whole UI, so a bunch of this stuff won't exist. We start a standard vector. So a vector is an array of an unknown size that we can continually add things to. So when we're going to create our options data, when we create it originally here, we don't know how big it's going to be. So by creating a vector format, it allows us to make it as big as possible. But when we can give it a size, we do, because it helps with memory size management. And the current menu item index 0, that's the display one. So what's the other one? Current option index count. Current option index count is because it has to go through the loop of 0 to X for each device. So it goes through 1, 2, 3, 4, 5 if it's sending me 5 options. And then it goes on to the next and it has to go to 0, 1, 2, 3, 4, 5 again, just to keep the IDs and everything managed. Then incoming data is that union messages. So that union that we created here. So it's just importing all those structures as the variable incoming data. So that's our like base setup for here. On the receiving end, it's a lot of similar stuff. So you've got a lot of the same inputs. We've got the button switches. We've got setting up a broadcast address. We've got that union of messages. Then we've got a bunch of default things set up that are specific for that device. So this is basically our color changer, our button inputs, all that kind of stuff. So we've seen all of these things before. It's just all the setup for the initialization of what this device actually does. The big thing that's important on the device is this structure option data. So like we said, that's formatted in this option data format here, and it's got a flag of option data. And then it's got IDs, which are based on these memory attributes. It's got its name, its type, its min and max. So for example here, this one's a type color, so it's min max 0 and 255, and then its default values. This is the information that is going to be sent to the server when it boots up. So the big important thing is that this is formatted correctly, otherwise the server doesn't know what to do with it. Oh, and it's also worth noting that this uses progmem. So this actually shows all of this in flash memory. Considering I'm using 186 neopixel bulbs, which can require 3 bytes per bulb, it's really easy to get to the end of the maximum memory size for ESP32. So all of this stuff I'm doing in flash memory. The read-write is completely fine, it's fast enough, it's not like a speed concern. So yeah, that stuff is written in and out of flash memory, which is what this progmem is. I think a good way forwards here, rather than just running through the code, is I'll show you how some communications happen, and we can look at how they transfer back and forward. So the first thing that happens is all of these devices boot up at the same time. The various clients come into their setup. They define their serials, their EPROMs, their pins, all that kind of stuff. Does this Wi-Fi mode, Wi-Fi STA, that's the ESP-NOW booting up the Wi-Fi mode. And then it does this standard initialization for ESP-NOW, and then sets the callback functions. So these are the name of 2 functions, on data sent and on data received. So these are just setting up the callback functions that attach to ESP-NOW. So what do you do when you send data, and what do you do when you receive data? Then we set up the peers, which is the MAC address of all the other devices that we connect to. So we're just broadcasting to say we're allowed to connect to these MAC addresses. And then read initial, which I'll come to in a moment. And then sets the display mode, which is actually the thing that the lights use. So the DRL lights mode comes on. The server, on the other hand, does mostly the same. Starts up the serial, starts up the Wi-Fi, starts up the pins for the input buttons. But then we run a delay of 6 seconds because we need the server to boot up after everything else has. 6 seconds is probably way too long, and we'll be able to bring that down. But for now, in the prototyping stages, 6 seconds is fine. So it waits 6 seconds, then it does all of its fire up, because we can pretty much guarantee that all of the other devices are on and ready by that point. Then it does a slightly fancier way of doing the peer definition, because we've got more than one peer potentially. And so it just attaches to all of those. And then we actually start doing things. So we do send option count request to current client index. So current client index starts at 0, because whenever you're doing an index loop, you start at 0. And what send options count request does is it goes to each device. So it knows it has, in this instance, 2 devices that it wants to talk to. So we set up a request structure. We give it the flag that it's a request that we're going to do. And one of our defined variables, request option count. So what it's going to do is go to each device one at a time and say, how many options are you going to send me? And we ascertain that early, we ascertain that first. And the value in this instance is unused. Then this is the line that we use to actually use ESP-NOW to send this request out. So this will broadcast, because I'm doing client index here, it's going to start and it's just going to broadcast to the first one in that list. So it's going to go to brake lights. It's going to say, hey, brake lights, tell me how many menu items you're going to be sending me. And then brake lights, if we go over to brake lights and we go for on data received, so this is the callback function that we attached, it's got a switch which switches based on the kind of message that's come through. So we know it's a flag request, so handle request is going to happen, and it's going to pass through the request and the value. So if we go to the handle request function, it's going to switch based on what the request it's sent is. And again, this is why we use these variables. So instead of just having that as case 0, case 1, which isn't particularly readable, we can have request an option count or request an option. So when it does send option count, it sends back a response of option count type, and it just attaches the value of the number of options. So the number of options we actually define here at the moment statically. This will be dynamic when it's created better. So then that response comes back to the server. So we get a received type on data received. It's a flag response. Again, it passes through the response and the value. So it goes to its handle response function, handle response. And if it is a option count, which it is in this case, it increments the options count by value. And the increment options count function, all it does is take that 0 that we started with up here, this options count, and it adds that number that we've just received. So this one's sending back 8, so this one has 8. And it just adds it to that thing, so 0 becomes 8. So if that's not the last device in the list of devices, we go to the next one, so we just increment that client count. So we go to the next device and we send that same count request to the next client. And so the next client can come back and go, in this instance, I've got 1 menu item. So it goes, great. And it updates its total. So that total is now 9. And when it does realize that it's the last one, it just resets that loop back down to 0 and does a send option data request to the first client, 0, asking for its thing, which is ID 0, which is the first part of its options list. So once we've ascertained from every device how many options it has, it's then going to go back to each device and do that number of requests one at a time to that client, asking for all of that information. So the send option data request sets up the structure as a flag, a request again type for an option, but then it passes an index saying this is the index of the option I want you to send to me. And then this one, again, it receives it in the onReceived function. It then comes again into that received request, and there's a send option value, which is very, very similar to the send option count. But this one's actually got the structure that's option data. So it's using a completely different defined structure, which means its flag is option data. It doesn't flag as a response when it comes back. It's flag as I'm sending you option data. So we have the flag option data here. And then when that is passed through from here, it handles that data and passes all that data to the handle add data option. And then we basically, all we do is break it apart, format it for the UI element, and then add it to that array, menu items array. So that's pushback new option. It's basically just going to add it to that array list. So then we have a localized store of all of the options that have been sent to us one at a time. And similarly to when it got to the last one in the list and it went on to the next device, this bit here, basically all it's doing is going, has device 1 sent me all of its options? No. Okay, well, I'll go ask for option 2. Great, thank you. Ask for option 3. Great, thank you. Option 4. Thank you. When it gets to the end of its list, it goes, great, well, we're done with you. Now we go to device 2. I know you've only got one thing to send me, so send me that one. Great, all done? Great. And then shuts down all of those requests and displays menu item 0. So that's what was just doing this print in the serial line. It's only serial output, really. Where it was there, all it's doing is a serial output because it doesn't really do anything at this point. Obviously, in the future, if we have a big, old, clever touchscreen UI, this is all going to have to change. So that's coming. So at this point, server has pinged all of the devices and they've all sent back what they do. Now, like I said, at the moment, I've only implemented the switching type, the on-off. So if we look at the enter button. So there's 2 buttons, next and enter. Next was the one on the left that cycled through. Enter basically just did a change. And again, these will be changed for UI elements, but at the moment, when I do an enter, we do a handle enter, which is with my handles, there we go. Handle set value press with the current item index. Like I said, at the moment, it's just a very simple one option at a time, and I'm setting that one that I've selected on or off. In reality, this in the future will probably have 10 on the screen, and it'll just need to know the ID of the one it's pressing, and this will change slightly, but for the time being, handle set value press. So I have pressed the button whilst I'm on one of them to do handle set value. And what that is going to do is get the current item from the array. So if I'm on the third option, it goes up to that array that I've stored by requesting all of the information from the other devices. It gets all of the information from that array element and stores it into current item. And then, based on the type of our current item, it'll switch what actually pressing that button does. Like I said, at the moment, I've only implemented the button type, the switch. So in this case, the new value is whatever the current value is inverted. So if the current value is 1, then it becomes 0, otherwise it becomes 1. It's dead simple. Whereas a type range and a type color will do something else as and when I get that far and actually build that bit. The thing that will be common though amongst all of these things is no matter how new value is calculated, they're all then sent the same way to the corresponding client with this handle set value request. So that has a client ID, so it knows which client that menu item belongs to, what its ID is, which is actually the same as the ID of it in the other client, and what its new value is. So it packages that bit of information up and sends that on with its new value. So then the client receives that information in its set value, because we've got a flag here, flag set value. We've got a set value type, and it's going to handle the set value. Then when handle set value runs, it again just extracts out all that information. It checks if the value that has been sent is valid dependent on the type. So we do this is valid value function, which I believe is right at the top. Is valid value, yeah. So it passes it the ID of the thing we're checking, the type of it is, and what its value is, and then we switch the validation based on the type of thing it is. So is it an active? So if it's an active, we just check, is it a 1 or a 0? If it's not a 1 or a 0, it's passed as something that it doesn't know how to use, so we ignore it. If it's a range, the range here will check the min range and the max range in the options, so in the thing that we defined at the start. Is it within the boundaries of the range that that item is allowed to be in? And if it's a color, is it between 0 and 255? These are going to obviously, again, expand into lots more types, but for now, we've got these 3 that it can validate. And then it'll send those validations back to set value here. So this will come back potentially, if it comes back false and saying it's not valid, then it'll just print error updating. Otherwise, it prints, changing this value, this label to this value. It gets the existing value from the flash memory. That's important. So it pulls the option from the flash memory. If the 2 values are different, then it'll update the memory state of that value. It'll update the memory, and the update memory is actually the EEPROM memory. So every time we make a change, these things at the top actually allocate to position 0, 1, 2, 3, 4, 5, 6, 7 of the EEPROM. So they correspond with the 2. Yeah, so it'll also update the EEPROM value so that if I, for example, deactivate neon lights and then I turn the car off and I turn the car on again, neon lights will still be deactivated. So it's important that it does both of those memory types. So the one that is just temporarily stored in memory, and then the long-term memory. And then send set value confirm. The big thing to note here is when I've sent from the server a thing to the client saying update this value please, I haven't at that point updated the UI to say that thing has done. That's like set and forget. So I could easily have it that I press the button changes, I send the command, and then I just assume everything's cool. What we've done instead is made it so that you press the button, it sends the command, and it waits for the command to come back and go, yeah, that's sweet, and then, and only when it comes back saying, yeah, that's sweet, do we change the UI. It means that the UI is actually reactive based on the response that it's getting from devices, rather than what it just assumes the state of devices is. So this one has a thing which will listen for set value. So this flag set value does a handle set value, which is here, somewhere here. Set value, there's handle set value. So that just then updates the value based on the value that's sent back. So we send the new value of, say, 0 to the device goes, cool, I've done that, and it sends back, I've set that thing to 0. So it's just confirming in both directions that the thing has been set to the right thing that we want it to be. That really is the crux of the communication of how things operate between the two. It's really just a case of the server trying to figure out what the state of all the devices are, and then know how to alter the types of things that those devices have on them. So they might be color pickers, they might be buttons, it might be a bunch of other stuff that we haven't got to yet, like a drop down list where you can choose one thing, or a bunch of images where I want to set a manufacturer logo on a gear stick, or there's tons and tons and tons and tons of stuff that this will be, but it's, like I say, only a few days into the development cycle, so it's early days as of yet. There are a lot more functions around these things, but I'll be honest, I think the server one, we've been through basically all of it. The only one that's a bit more complex is the lights device, because the lights device also has to have all the stuff in it that the lights device does. So all that stuff is around. One thing I did note, it's at the very start, is that we have this read initial. So what read initial does is go through that data list and looks, because we define this as a static memory thing at the start, but these we assume are going to be default values, but they might not be default values by the time we launch the application, because we might have changed something through the server, and we might have an improvement or a change to that value stored in the EEPROM. So what this read initial does is basically match the each one of the objects in the array against its EEPROM, and it says, is the value of the value the same, and if not, update it from the EEPROM. So the EEPROM takes precedent and overwrites the values as a setup function. So that does that, but then there's all the stuff around. Right colors hasn't actually done anything yet, but the display mode, for example, when I press the buttons, it flicks between the different modes, the DRL mode, glow mode, and break mode. The big thing that's a change here is, instead of just having, you know, when I press a thing, it runs display mode and it does the thing based on the mode, we have an if loop around each one of them, which polls that options value to see if that thing is turned on and off in its state management memory. Because instead of just receiving break mode and then activating break mode when we press the button, break mode might be turned off by the server. And it will know that because the value in the objects array and in the EEPROM will have been set to 0 for breaks. So the options object, we look at the break state address, which will just be it's just an ID. And we see, is that value equal to 1? Okay, is it switched on? Is it allowed? And if so, we actually do the thing, we set the color. Otherwise, we say it's blocked. So this little caveat is the simple way that it turns everything on and off. And it does that across all the different modes. It does it across the DRL mode. The caveat with the DRL mode is, because of the way NeoPixel lights work, you can't just stop sending it anything, because the lights will stay on. You have to send it and off. You have to literally send it a blank or a 0. So we do this set NeoPixel color of 0000, which is the 3 colors and the brightness, which inherently just switches off the lights. And it's the only one that has to do something in its else statement rather than a serial print. Everything else is pretty much as it was. It's just buttons that set the values. I've still got to do the thing with the color writing, for example, and changing the color based on the application. But now I've got to completely scrap that mobile app that I did that talked to the ESP32 and allowed me to change the color, because color selection is now a thing that's going to happen in the server. So my new mobile app has to connect to the server, and when it does, print out all the options, and then I can do my stuff there, set it in the server, and then the server just distributes it to the brake lights. So that's the big thing I've still got to change and implement. But you know, the majority of this is still the same. I did get into some issues. The fact, something to bear in mind if you're ever thinking about creating something like this, is because of the number of pixels that I had. The NeoPixel, Adafruit NeoPixel library was freaking out because of the amount of extra stuff in there, and like how all of this is starting to eat into memory. I was getting memory exceptions and I was running out of RAM, which meant that every time the device tried to start up, or the lights would start up, it would freak out and reset itself. So it just went through resetting loops. Turns out the NeoPixel library is really, really memory intensive. So there's this other one, NeoPixel Bus, which is really, really not memory intensive. And the calls are almost the same. You just don't have that NeoPixel library set up. You have this slightly different one, which is NeoPixel Bus. And when you do the calls to the various colors, you don't do it in the way we did it before. You do it as blah, 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 blah. You do it as this set NeoPixel color function here. Clear 2, and Clear 2 basically does set an entire strip to a thing, and we use the RGB colors. And also brightness doesn't work, so when we do set brightness to make everything bright or not bright, that doesn't work with that library. There's an include that does supposed to do it. For some reason it doesn't work, or I couldn't get it to work and I couldn't be bothered, so I just did a brightness adjusted color, which just adjusts the brightness values down. So a 255 will just get adjusted to 100 because of the maximum brightness allowances. So I just, you know, mathematically do it. Other than that, the commands to the NeoPixel are almost identical, and the fact that I'm not using animations or anything means it's really quite simple. But really, you know, this is it. This is the crux of what I had this idea of making, so this centralized system. So what are the next stages for this? Well, first and foremost, I actually need to finish this lights controller. And the good thing is, as long as I don't change the format, I can actually just install it in the car once I've got the custom PCB and everything arrived, hopefully some point this week, and all the components, so we can put that together, make it a bit more robust than it was, and actually install it. Then as far as the server goes, I need to develop how it handles different input types instead of just the switch type. How does it handle range inputs? How does it handle colors? How does it handle drop-down menus? How does it handle all these different things? So I've got to start implementing some of those. I have to put a proper UI onto it, because doing it in a serial output is not the way of doing it. Like I said, I'm probably going to use a 5.5-inch screen. I've found a bunch of them available that are apparently good for using on ESP32s, and most of them have UIs built into them. So for at least for the prototyping stage, they'll come with a kind of menu builder, which if you've ever used something like Material UI by Google, you just basically tell it, oh, I want to put a button here, and here's its value, and here's its label, and it does it all. So as long as I can match the data formats, that should be quite easy to make that screen, and then, you know, build all the interaction in for that. And then lastly, I need to make the mobile app, which talks to the server and, you know, spits out that same list of options, and then the mobile app is going to have to be able to interact with them in the same way that the screen does. And I've got a note as I'm just thinking about it. If I change something on the input screen, it has to update on the mobile as well as on the device. And similarly, if it updates on the mobile, it has to update the screen and the device. So there's all this like interconnectivity of things and like passive state management that I've got to consider and how it does that. But I think we can use a lot of the similar processes that we've done here and just keeping on top of that. So fingers crossed. So I don't know how long this video will have ended up being, probably somewhere between 45 minutes and an hour, and hopefully you've managed to follow along with what it's done. But do you now, having seen it work and having seen what I'm trying to do, A, think it's a good idea, B, think it's useful, and C, if you could build some devices that connect to and manage to it, what would you build? What do you think it could be useful for? I'd love to hear some ideas. I've got a lot of ideas myself, and I'm going to start building them pretty quickly. I've just bought a set of 10 ESP32, so I have a lot of runway to do. But for now, that's it on this. This is just an introduction to something I'm working on kind of in the background to making everything else more cool car stuff. I am sort of at the mercy of a bunch of deliveries, so I'm going to be waiting on a screen, I'm waiting on some PCBs, I'm waiting on a load of components, I'm waiting on a lot of stuff. Fortunately, we do have a lot of really cool stuff coming in the meantime. If you want to see how I actually took that mess of wires that didn't work in the car and turn it into a proper, you know, structured circuit diagram, and then a PCB board design, and then 3D PCB board design, and then actually get it all made and hopefully picked all the right components and everything. Well, I've got a video on that coming in the next week. So, you know, you've just got to hit subscribe in order to make sure that you keep up to date with all the cool project stuff we're going on, making loads of dope electrical and non-electrical wraps and interiors and stuff for our car projects. That's it for this one. Whatever you do with the rest of your day, have a wicked one, and I'll see you in the next video. Take it easy, peeps. Bye-bye.